Oh, hello everyone. I'll continue my physics from nature's perspective, and I'm nature. I'm the nature. I represent nature, and I'll talk for nature, and I'm a nature's messenger. And today's topic is still continue to discuss or I'll tell you nature's story, nature side, or the story, the gravity. The first of all, gravity is a collective phenomenon. Being collective, this particular perspective is also a perspective. It's not emphasized or is not particularly noticed in physics because people seem to be treating everything as individual, and being collective is rather important into the quantum mechanics because there are often several things involved. You know, like the double-slit experiment mentioned before. A water wave, you may consider it individual because water wave that is continuous. And electrons double-slit experiment, that's not an individual phenomenon. It's a collective phenomenon. You have to shoot electrons for a while to see the interference pattern. If you only shoot one, then you don't get it. And the same thing goes with gravity. If you only have one, say, particle in the universe, the simplest universe with one particle, and there would be no gravity. You need at least two particles, two things to have gravity. So last time we talked about Newton's shell theorem. Shell theorem tell us for the simplest atom, let's just say simplest atom, hydrogen, its center electrical charge of a proton, and the electrons negative charge around it, they do not cancel each other out, and therefore there is leakage or there is residue or for whatever the better term you might like to use. The and this residue and this leakage of electric fields, both positive and negative, extend into the universe or into the space forever, and actually again fill up the space. So with a magnet, we can kind of like understand or describe a hydrogen atom. See, I have a buckyball here, and it's a magnetic ball. A magnet, because with a North Pole and South Pole, once it's spin up, once you get somehow, if we could spin it with, let's say, South Pole at the center, and then the North Pole goes around the South Pole, and then you're going to have something similar to a hydrogen atom. And if you have two magnets or two buckyballs, and that's a H2, that's a hydrogen molecule. And if you have a whole bunch, and that this is what you have, this is what I have. And you may consider this is a collection of atoms, and since they are kind of shiny, and some even gold color, so I'll just use this represent a gold bar. as a gold bar, as all this collection of gold atoms, they are connected through a chemical bond or connected through electric fields or electromagnetic fields. Therefore, this is well understood that this is a local force, and further away, let's just say this particular atom, its electric and a magnetic force on this one over here is relatively small and it's negligible. And this is how this thing become one. What if you pull them apart? Say we do this. Once they became two pieces, when they are extremely close, they are still somewhat connected through or by electromagnetic force. Once they pulled further apart, further and further, let's just say this distance, and then the electric and the magnetic forces pretty much disappears, and then between them is gravity. But in reality, that gravity is still the result of extension of a magnetic environment, or the electromagnetic environment, and the electromagnetic fields of each atom add up. However, the total sum of the charge is still a zero, and therefore, when it's relatively further apart, it is either difficult. It is difficult to count each individual electromagnetic fields. So mathematically speaking, we treat this as one point with its mass as represent its personality, so to speak. Use one individual of a mass point represent all these atoms, and so is here. And then, of course, the magnetic part need to be mentioned because the magnetic bar aren't spinning. So certain arrangement of atoms, and this particular piece still have a magnetic force remain, although electric ones, because the electrics are dynamic, so their charges canceled out. So further apart, the electric characters disappears. But if atoms or in terms of magnetic force or fields are arranged randomly, and we may consider the magnetic forces or the North Pole and the South Poles, they are also canceled out. In that case, both are electric and magnetic and mutual. So, and this is our gravity. They are the total sum of each individual atom, their electromagnetic fields. All right. So I guess that's all I'm gonna say today. Alrighty. I'll see you later. Bye.